Hello viewers, you're welcome to Supermatics again today, and today we have lovely exponential expressions that we want to evaluate. This kind of exponential expressions require the use of logarithms. They require the use of logarithms to simplify them or to evaluate them. So let's get it started. Now we have that if 2 raised to power x equals to m raised to power y equals to n, and n raised to power z equals to 64. We have to evaluate 3x, y, z all divided by 2. To get started, we consider the definition of logarithm, or the link between logarithm and exponents, and the fact that if log a to base b is c, then it simply means that a must be equal to b raised to power c. That's the link or the relationship between logarithms and exponents. So this is what we are going to consider in evaluating this expression. Now, starting from 2 raised to power x, so we can say that if 2 raised to power x equals to m, then x must be equal to log m to the base of 2. Let's call that 1. The second one is m raised to power y. So if m raised to power y must be n, then it follows that y must be log n to base m. Log n to base m. Let's call that 2. Then the third one, if n raised to power z is 64, that also follows that z must be the log of 64 to base n. Let's call that 3. Now that we have representation for x, y, and z, the expression we want to evaluate is 3x, y, z over 2. And this is going to become 3 over 2 first, as the numbers or the constant there. X has been found to be log m to base 2. So that will be 3 over 2 times log m to base 2. Y has been found to be log n to base m. So that's times log n to base m. And then z has been found to be log 64 to base n. And if you like, you may also want to use natural logarithm. You have the same results. Now, with this that we have done, we are going to apply one very important law of logarithms, which we call the change of base, the law that has to do with change of base, in order to be able to evaluate this. So this is going to become 3 over 2. Then we can open a rectangular bracket. Now, this log m to base 2, we can express it from the law having to do with change of base. We can express it as log m over log 2, where the base could be 10 or could be natural logarithm. Now, multiplying this log n to base m can be written as log n over log m, while log 64 to base n is written as log 64 divided by log n. Then, looking at what we have here, we could see that there is log m in the denominator here, in the numerator here, and also in the denominator here. So they cancel out. Log n, we also cancel out log n, and we are left with log 64 divided by log 2, so that the expression becomes 3 over 2 times log 64 divided by log 2. Now, what we do here is to apply laws of logarithm also, where 64 can be written as an exponent, as a power. 64 is written as a power, so we have 3 over 2 times log 64 is 2 with 6 as exponents, then over log 2. Now from here, we recall that when we have log a to the power of b, it is written as b log a. So we apply that to this, and we have our expression becoming 3 over 2 times 6 log 2 over log 2. And here log 2 can take out log 2, and we'll be left with 3 over 2 times 6. And 2 goes in 6 3 times. We have 3 times 3, which is 9. The second one we have is an exponential equation, wherein we also use logarithm to evaluate. The question says that given that log 4 is 0.602 and log 5 is 0.699, we have to find the value of x in 5 raised to power x plus 7 equals to 4 raised to power 3 minus 2x. Now, to do this, we start by taking the logarithm of both sides. We take the log of both sides so that we have log 5 raised to power x plus 7 equals to log 4 raised to power 3 minus 2x. And for the fact that when we have log a raised to power b, it is b times the logarithm of a. So therefore, our equation becomes x plus 7 in brackets log 5 equals to 3 minus 2x, also in brackets, log 4. Then we open up the brackets so that the left-hand side becomes x log 5 plus 7 log 5. And the right-hand side becomes 3 log 4 minus 2x log 4. Now, what we do is we try to collect the like terms. Here we have a log with x in the expression in the log. Here also there's an x in the log. We bring them together, while the other ones which are just constants with the log, we also go together, so that we have x log 5. When we add this to both sides, we have plus 2x log 4, and that equals to 3 log 4, which is already here on the right hand side. Then when we subtract this from both sides, it becomes minus 7 log 5. And here we can factor x, which is the common factor. So x comes out, and we have in brackets log 5 plus 2 log 4. And on the right hand side, it is still 3 log 4 minus 7 log 5. Then we divide both sides by this bracket, log 5 plus 2 log 4, so that x is going to be 3 log 4 minus 7 log 5 divided by log 5 plus 2 log 4. Now, from the beginning of the question, we've been given values for log 4 and log 5. It is now time to substitute this value into the expression that we have and then solve it or simplify it in order to get the value of x, so that we have x to be equal to 3 times the value of log 4 is 0.602 as given, minus 7, log 5 given to us is 0.699, then divided by log 5, which is 0.699, plus 2 times log 4, which is 2 times 0.602. So here 3 times 602 will give us 1.806, minus 7 times 0.699 is going to give us 4.893. That divided by 0.699 plus 2 multiplying 0.602 is 1.204. 1.204. So the subtraction, the difference in the numerator is negative 3.087, while the denominator gives 1.903. And when we use a calculator or we use the table of logarithms to do the division, we have the solution, the answer to x, as negative 1.62, minus 1.62 to 3 significant figures. I believe you have learned something in this video. Please help us to share, like, leave your comments, your questions, recommendations, and suggestions in the comment section below or to the email attached. in the description below. Please subscribe to the channel and help us share the video to mathematics enthusiasts just like you. Thank you for watching. Bye. Watch out for more videos.